Boys and girls, I'm going to start another class on physics. In this class, I'm going to start a new topic, that is Faraday's law of electromagnetic induction. In chapter number 12, and the name of the chapter is here, magnetic effect of current. I repeat, the name of the chapter is here, magnetic effect of current. Now, boys and girls, before discussing Faraday's law, we have to know some important information about electromagnetic induction. I repeat, about electromagnetic induction. So, before discussing about electromagnetic induction, I need to discuss about induction. So, my today's topic at first is here induction. Induction. Okay. So, induction. If I give the definition of induction, then I must say that induction is an electrical process. By this process, you can introduce electrical charge to a neutral body. I repeat, by this process, you can introduce electrical charge to a neutral body. Okay, to a neutral body. Okay, from any charged body. But the main thing is here, without any direct connection in between these two bodies. I repeat, the main thing is here, there is no direct connection in between these two bodies. Okay, so I can say in direct definition format, the electrical process by which we can convert a neutral body into charged body, but without any direct connection. But what? Without any direct connection. Okay, so this process is called induction process. So induction process is the process the process by which we can convert a neutral body into charged body without any direct connection in between them in between them. Okay, without any direct connection in between them is called induction. Okay, so induction is a process. By this process, you can convert a neutral body into charged body. Okay, but there is no direct connection in between these two bodies. So this process is called induction process. This process is called induction process. Now, this process is called induction process. Okay. Now, boys and girls, the next step, listen to me. The next step, we can give some example of induction process. Okay, an explanation of induction process. Say, this is a metallic body. This is a metallic charged body, and the charge of this body is positive charge. This is a charged body, and this body contain positive charge. Listen to me. This body contain positive charge. Okay. The next step, we're going to set another body. Listen to me. The next step, we're going to set another body. Okay. Another body just closer of this charged body. Okay. And this is a neutral body. This is a neutral body. Okay. So since the second body is neutral body, okay, this body A, this body is body A, and this body is body then হচ্ছে B. Okay, so the first one is body A, and here the second one is body B. I repeat, The first one is here body A, and the second one is here body B. Okay. If I keep this body B just closer to the body A, if I keep body B just close to body A, then you can say that body A is a charged body. Okay, and the charge of this body is positive charge. And with the attraction of negative charge body, just like electron comes closer to this positive charge body. Electron comes closer to this positive charge body. Okay, from the atom of the metallic body B. So electron comes closer to this end. That's why this end becomes negative charge. I repeat, that's why this end becomes negative charge. And the atom who donate electron, those becomes here positive charge. So this side becomes positive charge. So this side becomes positive charge. You see, this side becomes a negative charge, and you also see that this body becomes containing two charge. But this body now is a charged body. Okay, this body now is a charged body. Okay, and the process by which we can convert this neutral body, into charged body, that process is called electromagnetic induction process. I repeat, that process is called electromagnetic induction process. Okay, now boys and girls, this induction process, I repeat, this induction process. Okay, so this process is the induction process, and the second body B is called induced body. Induced body. So what is called induced body? So what is called induced body? The body which one want to induced. Okay, that body is called induced body. So the neutral body, because of induction process, if it converts into charged body, the neutral body, because of induction, if it converts into charged body. Okay, so this body is induced body. And because of the presence of charged body, induced body becomes here charged. The first charged body is called inducting body. It's called inducting body. So this one is called inducting body, and the second one is called induced body. Okay, and at induced body there are two charge here. Listen to me. At induced body, okay, there are two charge here. At first, this charge is called induced charge. This negative charge side charge is called induced charge, or the charge which create at the closer end of inducting body. At the closer end of inducting body, okay, that charge is called induced charge, and the charge which one is developed at the opposite side of induced body is called, listen to me, at the opposite side of inductive body is called free charge. So this charge is called bind charge, and here this charge is called free charge. Okay, so free charge. Okay, now if I give the definition of, listen to me, if I give the definition of bind charge, so what is called bind charge? The electric charge which one is developed at the closer end of inducting body. At the closer end of inducting body, this charge is called bind charge, and the charge which one is created at the opposite end, listen to me, the charge which one is created at the opposite end, okay, of bind charge, that is called free charge. And this process is called induction process. You know, this induction process is a very slow process. Listen to me, this induction process is a very slow process, okay, and very unstable process. It's a very unstable process, okay, because of this induction process. Listen to me, because of this induction process, the induced charge is very temporary charge. When you remove this inducting body, listen to me, when you remove this inducting body, then you can say that the inducting charge, induced charge at body B becomes disappear. Okay, so this process is a very unstable process. Now, in next stage, okay, now in next stage, I'm going to introduce with you electromagnetic induction. The next step, I will use electromagnetic induction. So, electromagnetic induction. Electromagnetic induction. Okay. And first, we need to know what is called electromagnetic induction. Listen to it. The definition is by induction process. Induction process. We can produce by induction process. We can produce electricity from magnetic field. Or vice versa. It means that to produce magnetic field from electricity. Okay, it's called electromagnetic induction. It's called electromagnetic induction. What it does, we can say that by inducting process or induction process. Okay, by induction process, we produce electricity from magnetic field, or to produce magnetic field from electricity. We can produce electricity from magnetic field, or we can produce magnetic field from electricity. Okay, this is called electromagnetic induction. I repeat, this is called electromagnetic induction. Okay, so this process is called electromagnetic induction process. Okay, so in this case, it is very clear that we can produce magnetic fields from electricity, or we can produce electricity from magnetic field. So these two are vice versa. Now, I'm going to introduce with you the main step, or Faraday's law of electromagnetic induction. There are two laws of electromagnetic induction. Now, the first law of electromagnetic induction. First law of electromagnetic induction. First law of electromagnetic induction. Okay. Now, if the change of any change of magnetic field if any change of magnetic field or Simply I can call it magnetic flux. Magnetic flux inside any closed coil. Closed coil, then electromotive force will produce will be produced inside that coil. Okay. I repeat, the statement of Faraday's law, first law of electromagnetic induction, that is, if any change of magnetic flux. So, you need to know about magnetic flux. If any change of magnetic flux takes place inside any closed coil, then electromotive force will be produced inside that coil. Then electromotive force will be produced inside that coil. So the produced electromotive force, I repeat, in this case, the produced electromotive force. Okay, this produced electromotive force is directly proportional to this magnetic flux. Now we can say that we can produce electromotive force or voltage. We can produce electromotive force or voltage inside any closed coil if there are any change of magnetic flux. I repeat, if there are any change of magnetic flux. Okay. Now, before know about magnetic flux, we need to know two things. Number one is magnetic lines of force, and the second one is magnetic flux. Okay. So, in next step, I'm going to discuss with you. Listen to me. In next step, I'm going to discuss with you about magnetic lines of force. So, boys and girls, this is a bar magnet. Say, this is a bar magnet, and this side is north pole side, and this side is south pole side. And you know, boys and girls, very well that a bar magnet. Listen to me. A bar magnet, okay, or this bar magnet always show magnetic lines of force, and this magnetic lines of force comes out from the north pole, and always enter into the south pole. Okay, it always enter into the south pole, just like this pattern. Okay, if I draw this in at this side, then I can say that this part are called here. These are called magnetic lines of force. Okay, so magnetic lines of force. If I give the definition of magnetic lines of force, listen to me. If I give the definition of magnetic lines of force, then how can I say this definition? Listen to me, boys and girls. If I am to keep a north pole, a single north pole, a unit north pole, at the north pole of a bar magnet, okay, then the north pole of a bar magnet, okay, then we can say that this north pole, listen to me, this particular north pole follows the trajectory or path around this bar magnet from north pole to south pole. It goes from north pole to south pole. It throws out from the north pole and it enters into the south pole. It throws out from the north pole and it enters into the south pole. Okay. The path it follow is an imaginary path, and this path is called magnetic lines of force. This imaginary path is called magnetic lines of force. Okay. So magnetic lines of force is these lines of force. Okay. These lines of force are called magnetic lines of force. Okay. Now magnetic flux. Listen to me. Magnetic flux is that quantity. Listen to me. Magnetic flux is that quantity. It is the product of area and magnetic field. It's the product of area and magnetic field. So these two quantity, the product of these two quantities is called magnetic flux. The product of these two quantities are called magnetic flux. So this is a product. I repeat, magnetic flux is a product. Okay. Of which quantity? Number one is magnetic field, and second one is here magnetic field with area. These two things integrate to that the magnetic flux. Okay. Now, I'm going to discuss about this first law of electromagnetic induction. Faraday's first law of electromagnetic induction. Say, boys and girls, this is a coil, and I am to connect a galvanometer or ammeter with this coil. A ammeter with this coil. Okay, there, this is a coil. Okay, the closed part is a closed coil. Okay, it's a closed coil, and I am to put a bar magnet. A bar magnet is a north pole, this south pole. Okay, I have to keep this bar magnet in front of this. Listen to me. In front of this coil. In front of this coil. Okay. Now, 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 this north pole through magnetic lines of force and goes just this direction. Goes just this direction. Okay. It moves from north pole to south pole. Okay. From north pole to south pole. Okay. Goes here from north pole to south pole, enters into south pole. Okay. Now I can see here in this case, listen to me. In this case, only one lines of force pass through this coil. In this case, only one lines of force. These lines of force, only one lines of force pass through this coil. Okay, but if the relative movement takes place, which one is called relative movement? Same. At first, if I say that if bar magnet comes towards the closed coil, then number of lines of force, number of magnetic flux inside the coil changes. Number of magnetic flux inside the coil changes. Or if I take it away from the coil, listen to me. If I take the bar magnet away from the coil, okay, then can I say that the number of magnetic flux or number of magnetic lines of force changes inside the coil. So Faraday said that when change of magnetic flux takes place inside the closed coil, then an induced electromotive force will be produced. Then an induced electromotive force will be produced inside this coil. Then an induced electromotive force will be produced inside this coil. Okay? Inside this coil. And this is the first law of electromagnetic induction. Now, Faraday's second law of electromagnetic induction. Now, Faraday's second law of electromagnetic induction. So, second law of electromagnetic induction. This is the Faraday's second law of electromagnetic induction. Well, very good. In the second law, Faraday said that. In the second law, Faraday said that produced electromotive force is directly proportional to negative sign of sign of rate of change of magnetic negative sign of rate of change of magnetic flux. Okay, negative sign of rate of change of magnetic flux. I repeat, the Faraday's second law of electromagnetic induction. Produced electromotive force. Here, the produced electromotive force, this produced electromotive force is directly proportional to the negative sign of rate of change of magnetic flux. Negative sign of rate of change of magnetic flux. Okay? Now I'm going to give you some mathematical analysis. When magnetic flux is phi 1, this symbol is called phi 1, then no, if I say just like this, then it will be more convenient to you. Say initial magnetic flux is phi 1, so phi 1 equal to initial magnetic flux. Okay, so phi 1 is here initial magnetic flux, and then phi 2 is here final magnetic flux. So delta phi is the change of magnetic flux. Okay, and this change of magnetic flux takes place only for the time delta t. So delta t is the time. At this time magnetic flux changes. I repeat, at this time magnetic flux changes. Okay, so this is the required time. So I can say that rate of change of magnetic flux will equal to change of flux divided by change of time. Rate of magnetic flux will equal to change of flux divided by change of time. So delta phi divided by delta t will equal to rate of change of magnetic flux. Will equal to here rate of change of magnetic flux. Okay. Now, boys and girls, now Faraday said that produced electromotive force or voltage. Listen to me. Produced electromotive force or voltage. So here, electromotive force or voltage is directly proportional to the negative sign of rate of change of magnetic flux. The negative sign of rate of change of magnetic flux. Okay, I need to put a proportional constant here. So E equal to minus n delta phi divided by delta t. So here n is a proportional constant, and this n is called number of coil. Listen to me. This n is called number of coil. Okay, boys and girls, your homework is Faraday's law of electromagnetic induction. Thank you very much.